Hi, this is Drew. I'm going to be doing the tutorial for reaction circuits in the brain. So what we're going to be learning today is what is a reaction circuit, reaction time circuit, what paths does a reaction time circuit follow, how to actually remember any of this, and when are reaction circuits used. So the first thing to know is that reaction circuits are the path your brain follows when it reacts to something. Um, Not a great definition because it kind of loops back on itself. But basically, yeah, your brain follows the same path every time you have a reaction. So that's like if there's some sort of stimulus and you need to react to it, this path is followed in your brain. And as you can assume, that means it happens basically all the time. So, right, this is a test that I had people do. They push a green button if they are shown a green light, and they push an orange button if they're shown an orange light. Um, and then it was tracked how long it took them to react and what part of their brains went off. And this is the circuit that's followed every time you have to react to some sort of like stimulus or yeah situation you're in. So the general path of the circuit is the same one shown in the figure, but it's surprisingly hard to get figures on this. I just had to take a picture of the book. But yeah, it's input, thalamus, visual cortex, and then these are like sort of the timestamps of when all of that happened, and then like inferior temporal lobe, prefrontal cortex, premotor cortex, motor cortex, action. Um, but that doesn't really mean a whole lot. So basically, what this actual means is the path is one really quick, because with all these timestamps, it's a matter of small milliseconds, and two, it sort of follows the same trajectory of like analyzing the infant, doing like analysis of the information, right? Figuring out how to adapt to that information, and then actually taking the action. So right, like thalamus and visual cortex and visual identification pathway. That's like you're seeing it and you're actually putting all the shapes and colors together to figure out what it is. And then inferior temporal lobe and prefrontal cortex. That's your brain like doing all the math and the predicting of what would happen depending on various actions. And then the premotor cortex and motor cortex are actually queuing up your action, and then you take it, and that's like going down your spinal cord to your hand. Um, so how I like to remember this is sort of like thinking about it as a game. So when you're playing a game, right, the first step is like if your goal is to make pairs, runs, and combinations of 15, your first step is to just look at what cards you have, right? So if say this is your hand, you just want to figure out like what's actually in it. And then the second step is figuring out how to make that useful. So that's sort of like the visual step, is like looking at your cards, what do you have? Second step would be sort of this prefrontal cortex step of like making those combinations. So like looking like, oh, there's a run, and oh, those combine to 15. And then putting all that together would be sort of the prefrontal decision making side. And then actually playing your turn is where you get the points. So that's sort of the motor cortex and stuff. That's, putting cards down. And then like queuing up points would be the action. So yeah, it's sort of like easier to think about sort of in as the same steps of a game of you look at things, you choose what you're going to do with them, and then you actually start doing it, and then yeah, the consequences happen. So reaction circuits are used a lot. That's one thing the book wanted to point out. So first off, more complicated reaction circuits take longer times. Um, that's one of the things the book mentioned. So right, like let's say somebody had the same test they had earlier with the lights, but this time let's say they had a third light, and then they were shown like two signals, and they were supposed to pick a light based on the second signal, and the first one was orange and the second one was green. They'd be supposed to pick a green one, but they'd have a choice out of three buttons, and not supposed to pick the orange one. And right, that more like complex reaction they have to take would slow down these processes because you need to like have more colors you need to process, and then a larger decision to make, and then you're taking the action. Um, but also most scenarios use the circuit more times. So like if you see like an old friend or something, I think is one of the examples the book used, right? It's not like you're going to have one stimulus and then take one action. It's going to happen over and over. So not only is it like how long the circuit takes variable, also is how many times the circuit goes. So I like to think about this as like this one could be like how long a round of a card game lasts. Like let's say, right, a card game you play like 20 rounds. This one's how long each round lasts. Like how long does it take you to make pairs of these cards and actually play them? And then this one's like how many rounds does the game take? Right? Like this would be like cribbage, and cribbage it's usually like I don't know 15 rounds or so. Um, So not only is it variable in how long each round takes, but it's also variable in how, like, the game, if you will, how many rounds it's actually going to take to play the game. And both of those are variables that can be measured in like an experiment like this, for example. If they had to do a bunch of different things, each one would go through this again, and the more complicated ones would go through it longer. Um, and yeah, I think that's all to remember about visual reaction circuits. So yeah, thank you. Good luck on the Q&As.